Cool. Yeah. First of all, thanks for everyone who came. I know it's a good day, so it's a it's a difficult choice, and thanks for everyone who is tuning in live. So today I'm going to talk about building Java reactive microservices and on Kubernetes with Spring and JHipster. So a little bit about me for those of you who don't know me. So my name is Deepu K Sasidharan. I'm the co-lead of JHipster. I'm also a Java champion. I'm a huge open source guy. I have created a bunch of open source projects. Apart from JHipster, I also made a Kubernetes dashboard in Rust, JDL Studio, and few other stuff. I'm an open source aficionado, polyglot developer. Currently, mostly I work with Java, JavaScript, Rust, and Go. Also into Kubernetes and the DevOps stuff. I work at Okta as a DevOps developer advocate. I also write blogs on my website. I have write books and stuff, conference talks, stuff like that. Basically, developer advocate things. So that's about me. So does everyone here know what reactive is? Else I can just make that part short and then go, or maybe for the sake of people joining in, if somebody doesn't know. So reactive is nothing but handling huge streams of data, or handling asynchronous data streams, which are nothing but events sequenced in time. So that's about it. So whereas in your traditional MVC kind of architecture, you handle synchronous data. Every request is asynchronous. In a reactive model, you are working with event loops and stuff. Everything is asynchronous, and you basically handle events ordered in time. So like any other paradigm, reactive also comes with its own pros and cons. So on the pro side, reactive streams are easier to compose and manipulate compared to an MVC stream, especially if you are familiar with something like observables and stuff. You would already know it's easier to manipulate the streams, and since the streams are arriving ordered in time, you can manipulate them easier than taking a chunk of thing and doing whatever you want. You can also build highly interactive UX with reactive streams. So if you are encountering an application that is extremely interactive and responsive, it might be using a reactive backend, because you can have that kind of real-time interaction kind of thing, because you don't have to wait for everything and then send and receive data. You can do it in real time. So interactions can be much more nicer, much more real time. Reactive programming can also help you to avoid callback hell, which we are probably used to. If you come from Node.js world, you are probably used to that. Even in Java world, we don't do a lot of callbacks and stuff because we don't have callbacks. But something closer you might already be doing. Reactive systems, helps you to not do that, and have more like a it kind of. If you have worked with Kafka and these kind of things, then it's a similar model. So it's easier to subscribe to things, react to things rather than expecting something and waiting, So it's much more efficient. Async programming, yeah. So that part, of course, it's much more easier with the reactive system. They're also ideal for APIs that need to transmit large amount of data. So of course, for a traditional MVC app, a CRUD app, for example, like a normal CRUD app, of course, reactive is not going to be efficient, or it's not going to give you any benefit. But if you're building an API or a system that is going to handle, say for example, video processing, you're going to take in huge video files, you're going to or stream video files, audio files, or say log processing, like huge files of logs, for example, or audio, whatever, huge data sets. If you have those, then reactive systems can really really make it easier for you to manipulate them and build interactive systems with them, and also to handle them much more efficiently than like a traditional system. So when you have huge data sets, then you really start seeing benefits of reactive. Especially with reactive, you can have okay, I'll come to that. But of course, there is also a lot of downsides. It's way more complex than your traditional MVC architecture, right? It's way more complex to learn, way more complex to write, complex to maintain. They're also more memory intensive because of the event loop and stuff. So if you're running in a memory constrained environment, then probably not ideal. They're generally harder to debug because they are asynchronous systems, distributed sometimes, reactive. So they're harder to debug than their imperative counterparts. And the ecosystem is still not very mature. That's a very important point, especially for Java, because I think most of us we also go to Java because of the ecosystem, which is extremely mature. You know that things are battle tested. You can use that, for example, if you go to Hibernate kind of thing, okay, this is battle tested. I can trust this. So very mature ecosystem. Whereas for the reactive side, it's still not there. It's quite new. So you are not going to find mature libraries that easily. You're not going to get help on say forums or Stack Overflow that easily. So it comes with all that trade-off. Of course, on the Java world, there are three main ways to do reactive programming. There is the Java Flow API, I think introduced in Java 9. So it provides all the necessary interfaces and a very simple implementation. So if you're just doing a little bit of reactive in your application, maybe one API, two APIs, or something like that, maybe this is enough. You can get away with a Java Flow API without having to use a library. But if you start doing anything more serious or bigger applications with more APIs or complex use cases, then of course you would have to go to a third-party libraries. And two very popular ones in the Java world are reactive extensions and Project Reactor. So reactive extensions have similar libraries in many other languages. For example, for the Java world, we have RX Java. And if you are in a microservice kind of setup where you have applications written in many different languages, then this might be nicer because then you would have similar APIs across your languages. So because there is also RxJS, for example, and you will find equivalent in Go and Python or whatever. So it will be easier for you to use something which has very similar API. So the learning curve will be much less. If you're working across multiple applications written in different languages, it will be easier for you to understand, debug, or whatever. And finally, there is Project Reactor, which is what Spring also uses. It is this is what I'll also be using because JHipster uses Spring, and so we use Project Reactor indirectly. So both reactive extension and Project Reactor are quite good. You cannot go wrong with either. They have slightly similar-ish kind of APIs. You have the concept of monos and flux. So mono is events which are defined. So 0 or 1. That's it. So you either have something or not. Whereas flux is 0 to n. It's undefined streams. So basically streaming data. So mono is more like they are not going to give you any benefit over your traditional MVC. Apart from maybe number of requests per minute or something like that. Those kind of metrics may be higher on a reactive side because of the event loop and stuff. You might be able to handle more requests per second. Other than that, mono is not going to give you a lot of benefit. Flux, on the other hand, is ideal for streaming data. And if you have those kind of data that we discussed earlier, then yeah, then both the projects have nice APIs with for example. RX Java has APIs with which you can just work on your stream, like for example, map it, flat map it, or whatever. All these kind of manipulations they provide APIs out of the box, makes it easy. So these are all just setting the stage kind of thing. So I'll try to spend more time on the demo this time. I did this in JSpring, but how long do I have? 1 hour?
45.
45. Again? Okay. Then probably not. Okay.
If it's good, you have 500
Yeah. So with Spring Boot, so servlet stack, I think if you have worked with Spring Boot, you might be familiar with the servlet stack. Now Spring Boot also has a similar reactive stack. So as you can see, so instead of servlet containers, we have the 3.1 containers and Netty that takes care of that part. There is a reactive streams adapter, which is equivalent of the servlet API. Then there is also a reactive implementation of Spring Security. And of course, Spring WebFlux, which is equivalent of Spring MVC. So that would be that is what you would use if you are doing reactive with Spring. And then there is Spring Data Reactive Repositories, which underneath uses R2DBC for all the SQL databases. And of course, Mongo, Cassandra, Redis, they all have reactive implementations natively. So they are quite ideal. So when we started the reactive implementation in JHipster, We actually initially only had support for MongoDB and those, because R2DBC was I think still beta or something, didn't support all the databases. There were issues, so we started off with MongoDB as an experiment for reactive, and then when R2DBC was ready, we extended that to all the SQL databases as well. So this is the stack that you get with Spring. There are some things common between Spring MVC and Spring WebFlux, because as a programmer, when you if you are implementing reactive using Spring or JHipster or Project Reactor, no, especially Spring, then Spring WebFlux would be something that you would interact with. That will be your entry point. You might not care about the other parts that much, because that's like do once and forget about kind of thing. Whereas Spring WebFlux is similar to your Spring MVC. So that is what you would be writing APIs against. That is what you would be using to define your models and stuff, your REST APIs and stuff. So of course there are some things in common, like the annotations are quite similar. They both have reactive clients actually, and both can run on Tomcat, Jetty, and Undertow, but they actually have more differences than what they have in common. For example, with Spring WebFlux, the endpoints are more functional, whereas in MVC they are imperative, because it is one thread per request kind of model, where we have blocking dependencies for JDBC stuff, whereas in WebFlux we have the reactive equivalents, and WebFlux is also based on even loop concurrency model, which is quite similar to how JavaScript works. So you have a ever-running even loop, which basically processes your requests. So that's how the concurrency model works there. So the code-wise, not too different, I would say, especially for the JHipster implementations. This is example from JHipster's Spring MVC controller code. As you can see, we have the annotations that take care of stuff. So we do a JDBC call here, and then we just provide the entity back as a response. So it's quite simple. The same thing in WebFlux. So again, the saving the product and all those things are quite similar. But you can see additionally now since they are wrapped as fluxes and stuff, you can also use the built-in methods to manipulate them. Like you can map them, you can do data manipulations on that directly, and of course you still wrap them as response entities, but then you also wrap them as either mono or flux. This is not that interesting because it's mono, so 0 to 1. For same use case, flux would also be similar, because the code wise it's going to be similar. I think when you'll start seeing differences when you start manipulating the data. For example, if you have streams coming, I worked on a project where we were processing log files using RxJava, and it was quite interesting because the files would arrive in like batches and stuff, sometimes a few gigabytes, sometimes like a short file. So we had to encrypt those, so we could actually implement that encryption, streaming encryption, within this this flux kind of model. So it was much more, which was challenging, but we could encrypt streamingly and we could decrypt while streaming that back. So those kind of advanced things you could do with a reactive system, which of course, if you try to do this in MVC thing, you would have to take the entire thing, So this was faster because we were not doing the entire thing, because we were having some files which is so huge and we were running encryption on that takes a long time. Whereas when you chunk it and encrypt them, it was much more faster because you're also transmitting those chunks. So these kind of implementations becomes much more manageable in a reactive system. So of course, the question, do you need reactive programming? Absolutely not. Most of the times, I think a traditional MVC or imperative programming model is more than enough. You're not going to suddenly see any advantages, or you're not going to suddenly get a 2 times faster app or something just because you switch to reactive. That's not going to happen. This is definitely for specific use cases. Same as the microservice question. So it's not a silver bullet. So if you have programs that is going to handle or stream huge amount of data, if you have to manipulate huge amount of data, then reactive systems might be useful. Otherwise, you're not going to see any benefit over an imperative system. So that's about reactive before the demos. So JHipster, for those of you, I already spoke to some of you, and I think I was glad to see that a lot of you have already actually tried JHipster or even used JHipster. Very glad to know that. Um, again, how many of you have actually tried JHipster or know about JHipster? Okay. Oh, okay. Cool. Awesome. Okay. It's one of the most popular rapid application development platforms in Java. So if you're in Java and if you don't know JHipster, you should check it out. So you can scaffold modern web applications. When we say modern web applications, we are not talking about JSF on the front end or all those stuff. So we are talking about full JavaScript stack on the front end and a Java stack on the back end, which are actually the modern web apps on the Java world. So you can create a full-fledged CRUD application with Vue, Angular, or React front end and all the Java goodness on the back end with all your entity model. You'll get CRUD for all that. Other bells and whistles like your admin screens, Swagger integrations, or health metrics, and actuator endpoint screens, and all those bells and whistles. JHipster can also do more than just CRUD. It can, for example, you can generate CI/CD for your app. You can deploy to cloud with JHipster. You can generate Kubernetes configuration for your app, Docker Compose, blah, blah, blah. So a lot of other stuff. Quite popular. It can be used as a CLI. It's a Node.js project, so JavaScript project. So you can basically install it using npm and then just run JHipster to use it. Or you can also visit the website and use it as an online application. You can define your stuff there and get the application out as a zip file or onto your GitHub repo. So that's how you use JHipster. You might ask why JHipster? Because compared to many similar projects, JHipster is more developer experience oriented. So since all of us who developed it were also developers and we were using it, we focus more on making that experience nice. So everything works out of the box. You have a nice CLI to do stuff. Whatever is set up works based on whatever is the current trend, for example, on the front end world or back end world. Use the latest and greatest all the time and these kind of things. Of course, we also try to generate production code quality code. So this is an example from one of the generated applications, Sonar rating. So you can see it has quite good rating there. We try to maintain best practices on any selected combinations. Of course, sometimes we do slight adjustments here and there to make everything work, but we try to follow whatever a particular framework follows. For example, if there are Hibernate good practices, we try to follow that. If there is a Spring data good practice, we try to follow that. Angular best practices, we follow that. So we try and keep up to date all that thing. For example, when the React world started using hooks for everything, we migrated the code to start using hooks as well from the previous model. So we try to do all that. And of course, security, and ideally you could just create a project and start doing a UI and business logic. So that's the idea. JHipster started off as a web app development platform, but then we started doing microservices, which became far more complex. So JHipster can actually create a few microservice architecture. For example, today this is the architecture that I'm going to use. So this one will have a few microservices with a registry. Registry is nothing but a Eureka server combined with Spring Cloud config. So you get all the service discovery and stuff from Eureka, and you get Spring Cloud config for shared configuration. And Spring Cloud also helps with being the gateway and passing on the security tokens and these kind of things. Another architecture you can do is instead of JHipster registry, you can use HashiCorp console. It does the same stuff, or you can put traffic in front as a layer, or you can do the same with Istio, where you won't have a registry and you'll use Istio's built-in service discovery and stuff like that, and you'll use that as a gateway. So different architectures. I'm going to go with this. One of the important thing in this architecture is Spring Cloud Gateway. So actually, I'm also going to show OIDC with this example. And if you look at the code generated, Spring Cloud Gateway makes it so easy to make this entire application authenticated with OIDC, because just by adding a small filter, so for example in the JHipster code generator you will see something called token relay filter. So just by adding a filter you could make Spring Cloud Gateway to take the do the authentication, take the token, and pass it down to the microservices. So the microservice actually only have to validate the token. So it makes it easier to do these kind of things, because it is something that you would put on your gateway. And so with this you can do, say for example, authentication you can handle, you can maybe do rate limiting kind of things. So there are a lot more you can do with this. So Spring Cloud Gateway is an integral part of this architecture. And again, similar to the previous question, do you need microservices? Probably not. Most of the times, like I think, yeah, I was talking to someone and like they mentioned they were like a 5-member team maintaining like 20 plus microservices. I'm like, why? And I was once in a team where we were like 3 or 4 people. We were maintaining like 6-7 microservices, which was a stupid thing to do in hindsight. So of course, not for everyone. Bigger companies, who has the resources, it's fine. But for smaller teams, I think monoliths most of the time works better. Your microservice, of course, comes with its own complexities. It needs its own, if you go microservice, you would have to probably do a distributed tracing then, because you don't need that in a monolith, right? You then need distributed tracing. You then need something like, say, maybe Kiali for observability. You need a full-fledged observability for your things. So you're just, right? Like, so of course, no, again, not a silver bullet, only when there are challenges that can be solved. So I think I have enough time for demo. Okay, 7:30, right? Until yes, I have 30 minutes for demo. Cool. I'm gonna switch to. Yeah. Okay. I already have the cluster. For example, you need a Kubernetes cluster for the demo. So I already created the cluster so that I don't have to spend time. So if you want to try this out, then these are the commands I use to create the cluster. So I have a cluster with nodes and everything. Where are my nodes? Yeah, so I have 4 nodes. So this is the cluster that I have to be using. And I'm going to use JDL for this. Should I make it bigger? Is it visible? The font? Yeah, fine.
Cool. No, a bit bigger.
Bigger, okay. Okay.
Yeah.
Cool. So, yeah, I'm going to download. I'm going to download a JDL file that I already have. I'm going to use that. Yes. So JHipster has its own DSL where you can define. So you can also use JHipster as a CLI where you type JHipster, then start answering questions in the CLI. You say yes to this, yes to that, blah, blah, blah. Or you could also provide it as a configuration file. We call it JDL, which is JHipster domain language. So you can configure applications. You can configure your entities, enums, relationship between entities, and stuff like that. So you can define and you can also define your deployment in the same file. So you can have one file and you run one command. Basically, it recreates your project from your application to your entities to how you're going to deploy it. So everything can be recreated using this file. So I'm going to use this. And so as I showed in the architecture, there are 4 applications. So the store is going to act as our gateway because I have mentioned the application type as gateway. So JHipster knows to make it a gateway with Spring Cloud Gateway and everything. It will also have the front end with React. And we would have the microservices without a front end and just providing the APIs. and these are of type microservices. If you say monolith instead, then it will create a monolith. And of course, we have entities, which is very JPA-ish definition. So you'll, I think most of you, if you are familiar with in the Java world, I think, or JPA or something like that, then I think you are good with it. Is it good enough? Yeah, I think it's a bit smaller. Is it okay, the size? Again, where was I? Entities, yes. So very JPA entities. You can do enums. You can define relationship between entities. JHipster takes care of creating everything. And since these are microservices, the front end would be created on the gateway instead of on the services itself. You can also do micro front ends with JHipster, in which case the front end would be generating those services, and then everything will be aggregated on the gateway, using micro front-end framework for the appropriate front end that you chose. Okay, was I? Okay, so I'm going to run the command JHipster JDL. Yeah. So this is going to create everything. So this is basically generating each application, scaffolding each of those applications with their entities and stuff, then running the commands needed. For example, running npm install on the gateway application for npm to download the world, since we have a front end stuff. And it's going to take a minute or something. The funny thing is the npm install takes most of the time in this process. I think it's like takes 90% of the time. Everything else is fast, so we have to wait for npm install. So if you look at the generated code, you would see them organized in folders for each application. So we have our store application, and if you go to src, you can find the Java source as well as the JavaScript client source. So this one is a React app on the front end, and we have the traditional not traditional, reactive, because in the JDL we also said oops, no, this is the, okay, I used the wrong file.
It's JHipster, so you can regenerate it.
Yeah, I can just regenerate it. So I'm gonna do that, but that means I'm gonna waste some time. Yeah, I can keep the other one. What else? I don't need this as well. Yeah, this is not the right file. Let me just quickly copy the file. I think I have it. Yeah, sorry, this was the right file because the other one was using Istio. So this one, pretty much the same thing. The only additional thing is this keyword here, which says reactive true. That's the only difference, and probably some difference in the deployment part. That's probably the only difference. Yeah, that's the only difference. So I'm gonna run it again. JHipster JDL app.jdl. Sorry about that. Yeah, whatever I said earlier is kind of the same, but I think the app that was previously generated was using Spring MVC, the traditional one. Whereas here, if you look at the Java source, you can see on the website, yeah, we are using, yeah, we are generating reactive endpoints. Of course, everything that JHipster generates is going to use mono because CRUD is always like CRUD by default is defined. Unless you have specific use case, you would have to change it to Flux. But whatever JHipster generates is using mono. So code wise, I won't say it's that interesting to look at because it's basically looks exactly same as the MVC code with everything wrapped around mono. So that's only difference. Of course, if you look at the security implementation and stuff, you would see this using Spring Reactive Security. And also, if you look at the repository side, you will see that this one is actually generating everything required for reactive repositories. It is not using, similar to what Spring Data had. It is generating methods for you, very similar to what Spring Data would do. But with you can see here that these are Flux methods, for example. So it gives you that. So it's like a step on top of what Spring Data would do for traditional architecture. So here it would generate whatever is missing from the stack, for you to use this app in a reactive way. So it will generate everything for you. I would say the repository side is quite interesting to look at due to all the R2DBC stuff that is being done here. What else is interesting? Domain classes, not very interesting. They look quite similar to what you would have with your traditional architecture as well. So again, I recommend that you try this out, look at the generated code if you're interested, and see. You should be able to, if you're familiar with the Java stack, especially Spring, you would be at home because it follows everything, all the good practices that put forward by Spring. It uses layout and everything, which is quite, common in the Spring world. So I think it is done. Yes. So we have generated. We can now build our images and put them to a Docker repository. I have already done that, so I'm not going to, because this will take another 5 minutes. I don't have that. So basically you go to each folder and run the Gradle command, and JHipster comes with Jib integration. So Jib is a Docker image building tool for the Java world. So you have a Maven and Gradle plugin. It makes working with Docker images quite easy. You don't need a Docker file for this because you can provide everything as a Jib configuration, and it takes care of building Docker images. And it's even better than using Docker directly because this does the layers in a much more efficient way, catches and does the layers in a much more efficient way. So take a look at Jib if you are doing a lot of Docker stuff on the Java world. And if you're not using Jib, then I would recommend taking a look at it. It can give you a lot of benefits. And I said I was going to do YDC. Don't know if I have the time for that, but I'm going to try. Of course, since I work for Okta, I'm going to do IDC with Okta. So I'm going to use the Okta CLI to create a JHipster app. So the CLI has configurations to create a JHipster app on the Okta tenant and configure it with the roles required for JHipster and everything. So I'm going to go with the defaults, all defaults, because it is pre-configured for JHipster. Since I said Okta apps create JHipster, which is specific command to do a JHipster app. So it has done that, and let's see. Okay, and it has created an N file with all the details that I would need, like my issuer URL, my client ID, and stuff like that. So next you would have to update your registry. Because we use Spring Cloud Config, we can update one file and have that configuration distributed to all our apps. That's the advantage of using Spring Cloud Config. So we would go into the Kubernetes stuff generated. Oh, I think I didn't go into this before. So yeah, since we defined the deployment using Kubernetes, that was also generated. So you can see for each application, a deployment manifest is created with whatever you would normally do in a production app. Everything's set, like for example, pod affinities, you have a nice init container setup that waits for your database and stuff, all the things that you would actually do in your normal setup. It is all there. You would have a manifest for your database if you're going to run them on your own, or you can switch them out to your service provider one, services and everything. And for each application, and of course the registry setup. Since we are using registry, if you used console, it will generate the console one. If you use Istio, it will generate the Istio stuff. So it will take care of all that stuff when JHipster take care of that. So in the registry, we have a config map that is defining the shared configuration. So this one is provided to all the applications. So we would, do I have it? Yes. So we will add the OIDC configuration here, and that's it. So this is this would be the only thing that we need to do in order to distribute the OIDC configuration. So I'm going to copy everything from here. My client ID. And my client secret. Of course, you should never put your secrets in a Kubernetes config map or Kubernetes secret even, because they're technically not safe. I mean, even Kubernetes secrets are just base 64 encoded strings, so you can decode and see what it is. This is not the ideal way to do it. I'm just doing it to demonstrate. I'll show you how to do it in a safer way for this particular setup. Of course, there are many ways to do it, but for this particular setup, there is a safer way to do. And next thing you can do is, since we are using JHipster registry, it has a OIDC mode already pre-configured. You just need to enable a profile and it will work as an OIDC. It will look for the OIDC configuration and try to authenticate with that. So we have to add, we have to go to the registry, find its configuration, the active profiles, and add the OAuth2 profile. So this will automatically make the registry, take this configuration and log in using your OAuth credential. And once you have done all this, you can actually deploy. So let's see. I'm going to the Kubernetes folder. Again, there is a handy script here, which is nothing but a bunch of kubectl applies. You can also do it manually, but yeah, if you can script it manually, right? And of course, it also provides customize and scaffold configurations. If you're using customize or scaffold with Kubernetes for changing your variables or changing your configuration, then of course you have that already. You can just put in the configuration. There are files, a customization file generated and scaffold file generated. So you can start adding stuff there and manipulate the generated one without having to touch the files if you prefer doing it that way. So let's apply the kubectl file and let's watch our ports. I'm going to watch only the JHipster namespace here. So you can see the deployments have already started. So next, while the deployments are happening, let's, this is what we did. So the secrets part, right? So you never put your secrets in Kubernetes file, right? And natively, there is no way in Kubernetes to actually do this securely because Kubernetes secrets are not actually safe. You can decode them and see them, right? So ideal way for this particular setup, since we are using Spring Cloud config, we can actually use the encrypt decrypt endpoint provided by Spring Cloud config. So these APIs, so you need to, of course, again, this is not the safest, I would say, because for this to work, you have to provide an encrypt key, which is nothing but a UUID base 64 encoded. So you would put the encrypt key as a Kubernetes secret, and then you would pass that down to the registry. And the registry would use that encrypt key to encrypt, decrypt, whatever you provide in the UI. And once you have so you would run the application with the plain text secret like I did now once, and then you would use the UI to encrypt or decrypt your keys. And once you have that, then you can actually go back here and you can replace this with the ciphered value with the keyword cipher on the front. You would replace this, and registry automatically, whenever it encounters any configuration with the that starts with the keyword cipher, it will try to decode it using the encrypt key. So this is slightly more secure than putting plain text stuff here, but still not the most secure thing because your encrypt key is still a Kubernetes secret which can be decoded. So someone can take your encrypt key and decode this stuff. So still a possibility. So ideal would be to use a service like Vault. Or Kubernetes seal secrets is another good way to do this. So these would be ideal way to secure, secrets on Kubernetes manifest, especially if you're going to put this in a repo or something, right? And I would never recommend what I did here, I just did this for the demo purpose because that is going to take more time. This has all chances of accidentally getting into a Git repo, right? So look into Kubernetes seal secrets, which is quite nice. But ideally, if you're on particular cloud, you could use their key management service. AWS, all of them have some sort of secret management solution, so you can use them, and most of them are quite well integrated with the Kubernetes service they provide, so they kind of work nicely. So that would be what I recommend. So let's see if our deployment is done, and I have 2 minutes. Yes, so everything is running here. I'm going to so I'm going to run the app. So we have our gateway application. Let's sign in using Okta. So we are signed in. We have all our entities here. So this entity customer comes from the store itself, but product, for example, it comes from the microservice. So for example, you can create a new order. So this is calling the microservice APIs to do that. We also have some administration stuff. For example, you can see what endpoints this gateway is talking to. That means all your applications, their endpoints and stuff. You can also see metrics, for example, from the Spring actuator endpoints, health from the actuator endpoints, and you can see all your configuration that is currently being run. And you can also have log, the real-time log, the logs based on logback. So you can actually change the levels from the UI if you like. Some of these are available in dev mode, some are available in production. So you don't see any Swagger stuff here because I'm running it in production mode. If you run it in dev mode, you'll also have your Swagger endpoints for your API. So you can try out and do all Swagger stuff. And of course, you have some account management stuff. Since it is OIDC, you don't have other URLs like register, change password and stuff, because you'll do that into your OIDC tenant. So for example, if you wanted to make this application use JWT instead of OIDC, right? So you only have to do one small change. You just have to change this line so you just have to change this to JWT for all the applications. Just change to JWT, regenerate, and you have the exact same thing, but using JWT for authentication. Or you change to session and you have session-based authentication. Okay, for microservices, that's not going to work. So it's just OIDC and JWT, but for monolith, you can do session-based authentication. Similarly, anything else, it's just changing here. Postgres, if you're on MySQL, just change here, you have MySQL. For example, I have Postgres for some database, and I have, where is my notification? I have MongoDB for this. And everything that JHipster generates, for example, for the notification Kubernetes stuff, it generated a clustered MongoDB configuration and with a lot of scripting, because all those script was required for it to work well in the generated setup, find other instances, cluster with them, and blah, blah, blah. So JHipster takes care of all this. So let's also take a look at the registry. So I'm going to go close this. So the registry is running in 8761. Okay. What did I do? 8761. So yeah, the registry, again, it automatically signs in using your OAuth credential, because I just logged in using my OAuth credentials. And you will see a small dashboard with stuff. You have your Eureka instances. You'll see how many instances are running per application and stuff. History of registrations and deregistrations in the registry, your replica related stuff, your cloud config. This is where you can actually change config here, and it will be, if you change the configuration in this UI, it will be actually refreshed in the applications. And this is the encryption that I spoke about. So once you have the encrypt key set up, then you can put any secret here, you can encrypt them and also decrypt them here, and put them back. So this is slightly nicer. You have so you'll basically put it with this particular keyword cipher. So that's how that's what I explained earlier. You have SSH stuff. If you have SSH configured, then you have those as well here. So that's basically about it. Think I went through everything. Additional resources. These are some of the blogs that we have on the Okta developer blog related to this. For example, there is a really good one from Matt where he explains in much more detail how to do the secrets in Kubernetes properly and stuff. There is a blog about how using Spring Vault, which has a nice Vault integration for Spring, which you can also use to secure your stuff. The video is similar, but with Istio. So if you are interested in that, you can check that out. That's about it. So the takeaway that I would expect people from a talk like this, because this is more of an introductory kind of thing, a takeaway that I would expect is you know that there's this tool that can do all these things, and you can use it for different purposes. You can use it for learning. I used JHipster for learning a lot these days because I'm a developer advocate now. I don't actually do any production code anymore, so I don't build applications other than the OSS stuff anymore. But if I really want to learn, say for example, I'm familiar with how JHipster's this architecture works with registry and everything. So when I wanted to learn Istio, it was easy for me to take an application that was done this way, change everything to Istio, regenerate a separate application, and compare and see what I needed to learn. Like see the difference and see, okay, how the service discovery is being handled, how is traffic management handled, how is quota splitting handled. So all these things I could compare and I could learn. So I use it as a learning tool. So I hope you would also use it like that. So JHipster is not the intent of this project was not for companies to take it up and create projects. It was mostly educational. So we wanted people to try it out and learn stuff. So if you don't know how to integrate, say, React with a Java application, so try this out. You don't need to learn anything to try it out. And once you have the application, see how it is done. So that's what I would expect. So thanks, folks. I'll be happy to answer any questions. Sorry, I took 2 more minutes, I think, to 5 more minutes. Thank you. Oh, and that was the UI I used for Kubernetes was KDash. That is what the dashboard that I built. It is in Rust. So somebody was asking me about that.
Questions from the group here?
No? Nice. Either I explained really well or it was really not interesting.
I have a question
Wait,
about
I have a microphone.
I have a question about you told about micro frontends.
Yeah.
Which, but are they already part of JHipster?
Yeah.
Because
It's quite recent.
yeah, I cannot
you mean like-
find that you can choose it from, for example, JHipster Online.
Not from JHipster Online, because JHipster Online actually is not kept up to date with the CLI, because everything happens in the CLI, and the UI on JHipster Online is a separate thing that you have to update. So it doesn't move as fast as the CLI. So yeah, if you want to try the new stuff, then I would say CLI, because it takes few months, and whenever people get time to update it, it's a bigger process. So yeah, so you can try it with JDL or using the CLI directly. It's quite new. I won't say it's production ready. It's still kind of experimental, like Reactive, which is also quite experimental. There are rough edges, but yeah, it kind of does what it promises to do with the federation on the front end with Webpack and stuff. So if you want to see how it's there, but I don't know if it would be production ready or not. Again, depends on if you really want to do micro frontends today, which is also quite immature technology, right? So if you are doing today, then, and if you do it by hand, probably you'll end up doing the exact same thing, and then you can decide if it is production ready or not. So,
okay. Thank you.
Thank you.
Oh, do you have a question? Yeah, perfect. No, go ahead.
was a Quarkus and Micronaut already included in the JHipster?
Not
an
in the
alternative?
core, but there are, so JHipster has the extension mechanism called blueprints, which provide additional functionality. Like, for example, if you want to do exact same thing in Kotlin instead of Java, then there is JHipster Kotlin, which is an extension that does that. Similarly, there is JHipster Micronaut and JHipster Quarkus, both at different stages of development. I won't say they are as featureful as the base JHipster, because some combination might not be working in that. But if you just want to have Micronaut or Quarkus instead of Spring Boot, yes, there is an option. So basic stuff is all there, but if you look for some specific combination, it might not work there. But yeah, the basic stuff is there. Basic CRUD applications and basic microservices you can build already using them.
I will have a look. Thanks.
Any more questions? No? Then a warm applause.
Thank you.